Okay. So again, I just want to reiterate for this afternoon's event, we'll be using the chat function as our main source of communication. So when you're using the chat, just make sure to change that little blue button from host and panelists to everyone. And as a reminder, we're all here to learn something and have a good time. So let's remember to be kind and courteous to each other. All right. So we're very excited to have you here. I want to welcome you to Flatiron School's Ode to National Burrito Day, Folding Your Software Burrito, Best Practices and Meeting Deadlines. My name is Catherine Sommerfeld. I'm the Director of Marketing Campaigns and Events here at Flatiron School. Part of my team's job is hosting these free introductory workshops to give you all the opportunity to meet some of our instructors and get a better feel of the Flatiron School experience. So without further ado, I'd like to introduce our host for today, Katie Cleland. She's a senior curriculum developer here at Flatiron School. Take it away, Katie.
Everyone, my name is Katie, and as Catherine mentioned, today's talk is about folding your software burrito. So once you get access to these slides, if you already can see them, you'll see in the speaker notes at the bottom that there is a link to this article. This is the article that the talk was inspired by, called Folding Your Software Burrito. So in your own time, if you'd like to read over this article, you have the link now available within the speaker notes or the slide notes of this deck. So before we get really into this talk, I do want to give a quick introduction to me. Hi there, my name is Katie Cleland, and I am a senior Java curriculum developer on the software engineering curriculum team. Prior to working at Flatiron School, I worked as a software engineer in the DoD industry for about 5 years. And just a quick little fun fact about me, I love cats. I have 2 cats of my own. Their names are Riley and Poppy. They are the loves of my life. In my spare time, I volunteer at animal shelters. I've been doing that since I was 16 years old. So I work and socialize with the cats and try my hardest to get each and every one of them adopted. But we're not actually here to talk about my cats. I could talk about them for days. We're going to be talking about folding your software burrito. And by the way, I do have some notes off to my left. So if you ever see me just looking over there, that's just look where my notes are. So folding your software burrito, what do we mean by that? Folding your software burrito, we want to look at the execution, how to actually make the burrito, along with what are the constraints of making the burrito? For example, the tortilla size, the grocery budget we have, what's available, what kind of ingredients are available to us at our local food store. And all of that kind of makes up how we're going to create a burrito. But we're not actually going to be talking about burritos, although it is a reoccurring theme in this presentation. We're actually going to be talking about software. So when you're creating software, unlike a burrito where you can just cook it by yourself in your own kitchen, when you're creating software, you're actually going to be working with a team. And this team isn't always just composed of just other software engineers. You're going to be working with a wide variety of different roles. Some of these roles include product managers, UI UX designers, business analysts, software architects, system engineers, quality assurance testers, and even more roles depending on the team that you would end up landing on. And just to give you some context on what some of these roles might do in the software development kind of product making, the product manager, they're going to be focusing on the vision and the goals of the product. They're going to be working and communicating with the end users and the customers to figure out what the requirements are, what are the constraints, and by constraints for a software product, the customer might have some issues with budget, they might have a stricter budget, or maybe they're on a time crunch, so there could be some time constraints as well. Another role that you might be interacting with are business analysts. They act as a liaison between the marketing team and the engineering team. So they're going to be focusing on the client's needs and looking at kind of the market for the product that we're creating. So they might come back and say, hey, the market we're targeting for this product is pretty small. It's pretty niche. Maybe we can expand and generalize this product a little bit more so we can target a larger audience. And that's just kind of some of the roles that you would be interacting with as a software engineer. And in my personal experience, I've worked with all of these kind of roles, UI, UX designers, software architects and system engineers, along with quality assurance testers as well to go through and actually test the product. And before I go any further, I do want to pause here and ask if there are any questions. Let me pull up my chat to see if there's any questions in the chat. I'll pause here for a second.
I don't see anything to this point, but if anybody wants to include anything, please do now. Oh, I think we're good.
All right, let me continue on then. I'll move that back over there. So the focus of today's presentation, I talked a little bit about the constraints, like the requirements and the constraints such as the budget and the time kind of constraints that you might experience. But during this presentation, I'll be mostly focusing on the execution, how we're actually going to create the software product from a software engineering perspective. So let's get started and just assume that we have a brand new project that some customer is interested in. And when we get that project, we're going to go through something called a software development lifecycle, or SDLC for short. And this development lifecycle has 6 phases: the planning, design, development, testing, deployment, and maintenance phase. And oftentimes the maintenance phase is the last phase, but it could be considered where we could go back and plan again for maybe we have a larger feature we want to integrate into our software. And that's where we could go back into the planning stage and go back through the entire life cycle again. And I'll be going a little more in depth on each of these phases in the coming slides. So I will start with the planning phase. So the planning phase, I want to take a look at our burrito example again. So when we build a burrito, we want to create the best kind of burrito we can. We want it to taste good. We want it to have the best kind of ingredients, but we also need to make a probable burrito. And what I mean by a probable burrito is, again, we're looking at those kind of constraints, such as maybe we want Wagyu beef in our burrito, but we might not have the grocery budget for Wagyu beef, nor maybe it's not even at our grocery store that we could even buy it. So the product managers are going to be kind of looking at those kind of constraints and requirements. They're going to be figuring out what product it is that the customer wants, how we're going to build it, and under what kind of constraints we're going to do that. We want to build the best possible software, just like we would want to build the best possible burrito. And what is your role, maybe, is maybe a question you might be thinking in this phase. So in this phase, as a software engineer, you actually are a stakeholder because you hold a stake in this project. You are going to be able to give advice to the product managers and to the rest of the team. Maybe you're going to say, hey, I think a certain feature is going to take a little longer than you might think it is. And that's where the product manager can go back to the customer and kind of talk and renegotiate exactly what might be, what those expectations might be. So again, you're trying to build the best possible software product along with your product manager. You're all working together as a team. And often in the planning and analysis phase, the topic of a minimum viable product is going to come up. So minimum viable product, or MVP for short, is a product that meets the minimum requirements and features in order to present to the stakeholders and customers. This will produce an actual working product and give the customers a chance to interact with the product and provide feedback. So this could be something that comes up in the planning phase, just so you can get something a little quicker out to the market. That's one of the benefits of an MVP, is getting something out to the market, having your end users kind of interact and use it and play with it, and then provide feedback so you can continue iterating on that product even more. I do want to give an example of a successful company that has used an MVP kind of model, and that is Airbnb. So if you aren't familiar with Airbnb, it's a company where you can rent out a room in your house, or maybe you have a vacation house and you're going to rent it out for a certain amount of time to different tourists, or maybe people who are coming in for a conference for work. So that was a business idea that the founders of Airbnb had, but they didn't exactly have the money to get that business off the ground. So they created a minimum viable product. They saw that there was a conference coming to San Francisco, which is where they currently lived. And they used their own apartment, took pictures of their apartment, put up a little description of what their apartment was going to look like and everything. And they put it on their website. They actually attracted 3 visitors. And that is how their little business kind of took off, is with that minimalist kind of website. So this is what their website looked like. Airbnb, by the way, was previously known as Air Bed and Breakfast. And as we can see, it's a very, very simplistic website. And that is where they started. If we look now at where they are now, this is what their website looks like now. So I live in Colorado, by the way, which is probably why we're seeing a lot of Colorado kind of places, but this is what their website looks like now. It has a bunch more features. You can specify how many guests, what week, anywhere in the world you could possibly stay, where before they were just kind of targeting a design conference just to see if there was an actual market. So I thought it would be a fun idea in honor of National Burrito Day, which is tomorrow, I believe, to create our own little MVP. So we're going to create a little command line interface application. And this is, or CLI for short. And we'll go under 2 requirements: that we have to show the prices of our ingredients of our burrito, and that we also have to show what the final ingredients of the burrito are that we created. So now that we kind of have a plan in place, we can move on to the design phase. And the design phase is where we're going to be creating a blueprint. So we already have all the requirements and constraints, and now we actually have to figure out how we're going to make this software product. How are we going to make it work, and how are we going to make it look? Typically, this phase does not actually have any coding or programming. You're not going to be going in and writing any code during this phase. It's purely a phase for you to kind of diagram and write things out of how you think things should kind of be laid out in the code and how you think things should look. So there's a couple of examples. We can design mock-ups for how we want the application or product to look. So that could include how we want our application to be laid out, what kind of color scheme we might want to use, what buttons do we want to have on our website, and where do we want these buttons to be at. And that's a job that our user interface and user experience designers usually work with. So this is an example right here of a wireframe example. Wireframes are usually all in black and white. It's a very simplistic kind of design. Mockups usually include the colors and actual buttons for you to press, but I thought this was a very simple example for us to kind of just show today. So as we can see, this new thing product here, it's going to have its product name off to the left-hand side, some pictures, maybe there's 4 pictures, along with an overview, features, design specs down here in the tabs on the bottom. So maybe this is how we want our application to be laid out. We also, during the design phase, get to talk about the actual code and how we want that to kind of be laid out. So we can design how code works and communicates with different parts of the system. So here is a little diagram. This diagram is called a use case diagram. And in the design phase, you can create a bunch of these types of diagrams, along with other kind of diagrams that might be helpful. So what this use case diagram shows is it has 2 actors or 2 different types of users, and it shows how they're going to be interacting with the code and what parts of the code they might be interacting with. So overall, the design phase is about creating a blueprint so you can figure out how your code is going to work and look. And when you do the design phase correctly, it should hopefully save time during the development phase, because you're not going to be sitting there trying to figure out how maybe to code something and how it should communicate, because that should have already been done during the design phase. So back to our burrito example, our little application. This is a very simplistic use case diagram. It's nothing fancy. So there's only 2 options for our burrito menu application. Our customer can either come into a restaurant and create a burrito, or they can leave the restaurant. Now, my personal favorite phase as a software engineer is the development phase. So this is the actual phase where we get to write code, finally, right? So we have all of our planning and analysis, we have all of that done, we have our designs created, and up until now, we have been planning and writing out ideas on how to create this product, but this is where we actually get to take those ideas and turn them into reality. We actually get to create an actual working software product. It's important to note that this phase can take quite a bit of time. So there are different software methodologies that can help with managing this phase, along with some of our other phases. Some of the software methodologies include Shape Up, Agile, Waterfall, and we'll talk a little bit more about one of those methodologies later on in this presentation. But I thought it would be fun now to see kind of what our burrito menu application might look like. So I'm going to pull up this tool called IntelliJ. This is an IDE that a lot of software developers use. It has a lot of fun tools to help them create, to help them code and do some syntax highlighting. Anyway, so this little application, it says, welcome to the Burrito Builder. I did create this little application in Java, by the way, which is why it has this long Java 17 kind of command up here. Anyway, I want to walk you through how this application would work. So we're going to test it out. We're going to go ahead and actually create a burrito. And I'm going to add the things that I would like in my burrito. So I personally like steak in my burrito. I'm going to add some, oops, sorry, that was a typo. Let me start that again. I'm going to add white rice into my burrito. I don't need any beans. And now I can actually add my toppings. So I do want to point out that we do have our prices listed out here. So we can actually see how much each ingredient would cost. So for a steak burrito, it's going to cost about $10.20. Rice, beans are going to be free of charge. Most of the toppings are going to be free, except maybe guac and queso. So I can add the kind of toppings that I want at this point. So I'm just going to add veggies, guacamole. I will add green salsa. And let's say I'm done now adding the type of toppings that I want. So I'm going to enter done. And here it says you are ordering a burrito with the following ingredients, and it lists out actually all the ingredients that I chose and described above. So that is one of the other requirements that we had to meet. We had to show the user all the ingredients that they built the burrito with. We also have here the final price of what our burrito might look like. So the other use case in our use case diagram was we could either create a burrito or we can leave the restaurant. So we can go ahead and leave the restaurant, and it says, thanks for coming in, and the program is now finished executing. So that's just a quick little application that I created for this presentation of just how we might go through the process of developing a little burrito application. It's an MVP. So the next phase is the testing phase. And the testing phase is just what it sounds like. It's a phase where you are actually going to go through and test the software product. So typically when you're developing software, you're going to be actually doing some testing in that development phase. You might be writing some unit tests. You might be running your code just like I ran my code here with you guys. I tested out the product. And if you've ever written a paper and you've been writing it for a really long time, you might become blind to some typos and grammatical errors. Same thing happens with software engineers and software developers when they are writing code. So that's why it's really important for you to have it peer reviewed by another developer. And that's something called a code review. Once everything has been reviewed, everything is the way we like it, and the software product itself seems to be working, we're going to send it off to QA. So QA is quality assurance, and they are testers who are going to be testing the software product from top, bottom, left, right. They're going to be looking at everything in the software product to search for any issues and bugs. And there's quite a few benefits to testing. So it increases the quality of the product, and also increases the customer satisfaction by searching for any bugs now before we actually release it. It's also more cost effective and easier to fix any bugs now in the testing and development phase rather than doing it in the maintenance phase. We can also test for other things such as security and how vulnerable the software product might be, along with performance testing. So performance testing, it's going to be testing maybe how fast the application runs. Humans tend to be pretty impatient when it comes to technology, so we want to make sure that the product is performing up to par of those expectations. The next phase is the deployment phase. So the deployment phase, what this actually means is when you're a software developer and you're writing the code, you're typically writing in a local environment or a development environment that is not accessible by the end users. So when we're deploying it, it means we're going to actually make it available, publicly accessible to our end users and customers. So an example could be launching the product on a website where customers and end users can publicly access the product, or maybe launching an app and having it be available in an app store. And who actually performs the deployment will depend on the team that you're on. If you're lucky enough to be on a team that has deployment engineers who specifically have this job to just kind of deliver and release a software product, they'll be doing the deployment. Oftentimes, I've seen DevOps engineers and system engineers performing the deployment, but also you as a software engineer could also deploy this software product as well. I've had my hand in deploying systems a few times myself. And the last phase is the maintenance phase. So the maintenance stage, this is where we're going to be maintaining the software. It's really important to maintain the software, and our users are the best at finding bugs and issues with the product. So it's our responsibility to prioritize these issues and fix the bugs. Maintaining software continues to give the product credibility as well. We want to make sure we're always delivering a quality product and that we're trying to increase that customer satisfaction as well. Also, the maintenance phase, as I mentioned before, when I first introduced the software development lifecycle, is used for further improvement. So we could gain additional feedback from customers and end users during this phase. For example, they could say, I like this product, but I would like to see a little more of X and a little less of Y, possibly. And that's where we can incorporate that feedback and continue to iterate and make our product better. It's also our chance to implement any new features at this point in time. And that's when we would actually go ahead and kick off the planning phase again. So that is the software development lifecycle. And I know that seems like a lot, but luckily there are some methodologies that are in place for us to kind of help make this a little more manageable. I will pause here though before I move on and ask if there are any questions. So I'll go over and open up my chat.
So I think we have one from Athena asking about whether there's an advantage to taking online instead of in-person boot camp. I thought maybe from the perspective of a curriculum developer, you could answer that one. I can also provide my feedback.
Yeah, I can try to answer this question as best as I can, and I'll also have Catherine provide her input. So online versus in-person bootcamp, it really depends to me on your pace. And online, I think, is really nice if you're a little more, for the motivated kind of learner, you're going to really be learning a little faster and more self-learning, but you'll have your instructors and your coaches there to help you along the way. It's just a little bit more, I think, a little more flexible than in person. It's definitely more of that school structure. And some people usually need that school structure sometimes. So it really depends on, I think, your learning profile and how you best learn. But I will also pass the question back over to Catherine.
Yeah, I completely agree. That's pretty much my answer as well, is that it's really a matter of how you learn best. If you're self-motivated and you can keep yourself to a schedule, then I think the online program is fantastic for you. If you need more of a classroom structure, then I would suggest an on-campus experience. I think, that one is something that you are probably going to know best about yourself. And I think that, you can set yourself up for success that way. I think
Are there any other questions?
I had one hand raise from Anna, but I don't see an actual question. So Anna, if you have a question, if you could drop it in the chat or the Q&A, I can get that over to Katie for you. Other than that, I don't see anything else.
Okay, perfect. I will continue, and Anna, if you have a question,
Oh.
I'll address it after, unless Catherine, you see it?
I see. Is the on-campus program available for people of other nationalities? I know that there are some restrictions. I'm not that familiar with them, but what I will do at the end of this is drop a link to schedule a chat with someone from our admissions team, and they'll definitely have much more information about that. Actually, I'll do that right now, and then I'll do it again at the end of the program. Okay, there you go. Oh, and then I see a question from Athena on how are the different courses laid out. Athena, do you mean the online course versus the in-person, or do you mean our different disciplines? The different disciplines. Yeah, so they're all very unique. And again, I would say it might be best to talk to somebody from our admissions team, because I could probably sit here and talk about our different disciplines, but they're all very different. But absolutely, it's a good question. They just are all very unique. While some of them do share the same software, they all have their own specifics. So, and someone asked if they can find the code somewhere, Katie.
I can put my code up in GitHub and share it at some point. Just it'll probably be maybe a day later, so maybe tomorrow I can get that up on GitHub if people would like to see that.
Sure, and we can also drop the link to that GitHub in your presentation, because we'll send that out with the recording, so everybody will have access to it that way. Athena, I see your question, not all lead to software development. We have 4 different disciplines that we teach here. We have software, we have data science, cybersecurity, and product design. So they're all very different. They're all very different paths, honestly, and they do lead to different career paths. If you want to take a look at our YouTube, and I'll drop the link for that in the chat as well, there are a lot of different events for the different disciplines that might give you a better feel for how they all kind of uniquely lay out. You can also take a look on our website. And again, if you want to speak to someone in admissions, that link is there as well. But I'm going to drop the YouTube right now, because I think that and maybe our social channels are a good way to kind of learn the differences between the different disciplines. Great. Going to do that right now.
All right, awesome. So I really like that question too about the different disciplines, because you will be finding yourself working with other disciplines. So even though this talk is mostly coming from a software engineering perspective, you could find yourself as a software engineer working with product designers. For example, I mentioned those UI UX designers. They're mostly going to be looking at how the product should look and how it should feel. And by how it feels, I mean, how usable is it to the user? For example, when you click on a button, does it send you to some external link that you have to log into the product again? Or maybe it just sends you somewhere and it's a little easier, a little nicer. So you could be working with those kind of roles as well. You could find yourself working with cybersecurity as well to create a very secure product. Data science, I don't know too much about data science, unfortunately, but you could find yourself working with data scientists too, depending on the kind of project you end up on.
Yeah.
All right. So,
sorry.
oh, go ahead,
I just
Catherine.
dropped
Sorry.
in the chat on our Instagram and our TikTok, there's a series of reels from JP Ventura, who's on our data science team, and it explains the difference between a data analyst and a data scientist, which I think is really helpful. Also, just for everyone, we generally have an event every Wednesday from 1 to 2 Eastern, and we do each of the different disciplines once a week. So if you're interested in any of the others, just take a look either on the website or on Eventbrite or Meetup for what we have coming up.
All right. Awesome. I am going to continue on with the presentation now. And one of the last things I want to talk about with this presentation is a methodology called Agile. So this is a methodology you'll see all across the software industry. They're using it in almost every kind of industry. I've had various interviews and I've worked in different places where Agile is definitely valuable. So what is Agile? Agile is a software development methodology to approaching a project. It's an iterative process that takes a large project and breaks it down into pieces. So I have a little diagram here that I took from this website. You can see the reference there on how Agile works. You're going to go through those same kind of phases that I just discussed: the planning, design, developing, test, release, and feedback phase. The feedback is the maintenance. And Agile is kind of a subset, I would say, of the software development lifecycle, where you're going to be working on your software product in an iterative manner. So most of the times you're not going to be developing the most perfect software product right off the bat. Look at Airbnb again, for an example. They created an MVP and then they created a beautiful looking kind of website that is much more user-friendly and open to a larger market. So that's kind of what Agile is going to be looking at and trying to break down the project so that it's a little more manageable, a little more easier to swallow. And again, it's an iterative process of taking down that project and just building upon it to continually making the best possible software that you can. And another thing that I'd like to highlight is how Agile is all about communication and collaboration. So I do have a little link up here, and it's also in the slide deck of what is Agile. So Agile Alliance, if you want to ever get Agile certified or you want to know more about what Agile is, this is a great website to kind of delve a little bit deeper than what I'm going to go into in this presentation. But I do want to pull up the Agile manifesto for a second. And I just want to highlight right here, it values individuals and interactions over processes and tools. So what that means is you're going to be finding more value within an Agile environment by talking to other roles, other team members that you're working with, other software developers, over just kind of using different processes and tools like you might in a more traditional kind of software sense. And I do have a quote that I do want to read from the Agile Alliance website that says, "One thing that separates Agile from other approaches to software is the focus on the people doing the work and how they work together. Solutions evolve through a collaboration between self-organizing, cross-functional teams, utilizing the appropriate practices for their context. There's a big focus in the Agile software development community on collaboration and the self-organizing team." So again, Agile also not only fosters kind of that iterative process of creating the best kind of software, it's going to focus on making sure you're the best possible team. So all of those roles that I talked about in the beginning, you're going to all be collaborating together. And the more you can communicate and collaborate, hopefully your product will also continue to iterate and improve as well. So I do want to talk a little bit more about Agile. And to talk about Agile, I do want to go over some terms. Fun fact about Agile is some of these terms do come from the sport rugby. I personally don't play rugby, but I've heard there's something called a sprint in rugby. I think there's also something called a scrum. So Agile has adopted these terms because apparently rugby is very much a teamwork kind of game. It's all about teamwork, and so is Agile. So to take you through the Agile process of starting a project, you're going to start a project, and this project's going to start off with something called a kickoff meeting. And that's where you're going to learn everything about the project. That's usually the planning kind of phase. You're going to learn everything about the requirements, the constraints, who you might be working with, what the product is supposed to be, and kind of a plan. And once you kind of understand what the product is going to be, you'll create some actionable items to go ahead and create this plan. And from there, you can actually start something called sprint planning. So a sprint is a 2 to 4 week process, and this varies across each project. I've been on teams where the sprint is about 2 weeks, and I've been on teams where the sprint is about 4 weeks. It all depends on the project, and there's no right or wrong way on how long a sprint is. But either way, it's a time frame, and that is comprised of a group of user stories that the team thinks they can accomplish before the end of a sprint. So basically, in Agile, you have a certain amount of time to get a certain amount of work done. And the work that you're going to be working on is usually broken out into something called a user story. And that's the smallest unit of work in an Agile framework. It's not going to be a feature, but a goal into implementing a specific feature. So this is usually written pretty informally, but provides enough information to give the person working on it a starting point. An example of a user story could be maybe it's creating a login feature, or maybe it's testing the login feature. Or if we go back to our design phase, it could be designing and creating an entity relationship kind of diagram for a relational database. Maybe you're creating a diagram of how the data will be laid out. So those are just some examples of user stories. And user stories are usually estimated in story points. So what I mean by that is there's going to be stories that are larger and stories that are smaller, and how we can basically quantify what that story is by giving them a story point. So a story with larger story points is usually going to be typically more work. It also could signal maybe as a warning that that story should be broken down a little bit further. And then smaller stories with smaller points could probably be done in a reasonable amount of time. And estimating a user story is kind of complicated. I do have a link here on how to estimate a user story, and I do have it pulled up here. But for the sake of time, I'm not going to go into this too in depth, but I do want to just highlight that Agile estimation is a team sport, just because you don't know who might be able to bring a different kind of perspective. For example, you could be estimating a story on maybe a web browser. You want to support a different web browser, and maybe product management thinks that's going to be really easy, but maybe QA says there's a lot of more testing that has to go into that. So at that point, product management has to kind of go back and plan out and scope out exactly maybe how for that time and how long that might take. So once you kind of have all these user stories planned in a sprint, you'll actually start the sprint. And during that sprint, you're going to be having these daily meetings called a scrum. And scrums are supposed to be held daily, and they're also supposed to be roughly about 15 minutes. I've seen this vary across teams as well, but the convention of Agile is it's supposed to be held daily, and it's supposed to be a very short meeting, because all you're supposed to do is have all the team members come together, from the product managers, UI, UX designers, system engineers, and software developers, and have them come to this meeting with what they did yesterday, what they're going to do tomorrow, what they're going to do today, and if they're experiencing any roadblocks. And this is just a chance for the team to kind of come together, communicate and collaborate, and even express if you need help. It's so important as a software engineer to not sit there and bang your head against the computer for hours on end without asking for help. Agile very much fosters kind of asking for help and collaborating, because you never know who you're going to get help from. For example, I've been in situations where I wouldn't even think to ask maybe the new software developer in the office for help, and maybe they have the answer that I'm looking for on how to develop a certain feature. Or maybe it's, UI UX designer. They might share a different perspective to help me out on maybe a roadblock I'm experiencing. So again, Agile is all about that communication and collaboration. And after you're kind of done with the sprint, you're going to go through a retrospective, and that's your chance to come together as a team and say what you did well and what you would like to continue and what you would like to improve on. And this could be anything from the software product you've released now, new version or new release of your software product. It's continuing and iteratively getting better. But at the retrospective, it's also your chance to come together as a team and say, how can we as a team also continue to get better? I like to think of it as you don't all cross, the product doesn't cross the finish line until you all cross the finish line together. There is no man left behind when you're kind of developing software. And again, one more iteration of just how important teamwork is when you're developing software and working together and working with different roles as well. And that, I think, is my presentation. I do have some references here on this slide if you would like to go through them for just some more in depth. And that is it. Are there any more questions?
I didn't see anything else come in, but if anybody has any additional questions, now is the time. All right. Doesn't look like it. Okay, I'm going to drop. Oh, no questions, but a thank you. I'm going to go ahead and drop the links for the admissions team, our YouTube, and our social channels in the chat, just so that everybody has them. We will send this out again within the next few days, and we will get that GitHub link in there as well. I'm also going to put in the link to our upcoming events in case you want to attend another one. And let me just drop in this. All right. Okay. All right. Thank you again, everybody, for zooming in to join us today. Again, if you have any further questions about Flatiron School, you have the link to our admissions team. And as a reminder, you'll receive a copy of the presentation within 3 business days. If you want to see any previous events, head on over to our YouTube channel and subscribe. That's where everything will be, and that's where all future events will be as well. Thank you so much and have a great day. All right. Thanks, Katie.
Yep, thanks for having me.